Hello, I'm going to talk a little bit on how the STS OIDC flow works in Red Hat OpenShift on AWS, that is ROSA. This image here has quite a few components. I'll explain how the interaction happens across each of these components or services. The box here that you see below is the ROSA cluster, and the above one represents the AWS IAM components. So as you would expect, some of the core cluster operators in ROSA that needs access to invoke AWS resource APIs such as EC2 for auto-scaling of nodes or ELBs for creating service type load balancers, EBS volumes for PVs, its persistent volumes, etc. Which means that these operators require AWS credentials to invoke these services, as to invoke AWS APIs. When the cluster runs on STS mode, there are specific AWS operator roles that are created initially during the cluster install process. And these roles will need to be assumed by the AWS SDK client code that runs within these operators. However, an operator cannot just assume these pre-created roles without proper authentication or authorization, right? For authentication, AWS gives you uh, a few options. AWS supports the configuration of IAM OIDC identity providers that lets users to configure an external IDP service of their choice that supports OpenID Connect standard, for example, Google or Facebook, etc. It also supports JWKs or JSON Web Key Set based external IDPs that use an Amazon S3 bucket to publicly host the JWKs endpoint. That's exactly what ROSA does, or what ROSA uses here. A little bit more deeper about how this kind of IDP works. ROSA creates a cryptographic key pair during the cluster install process, and the public part of the key pair is stored in this S3 bucket in a specific folder structure. This bucket has the JSON web key set with information such as where the public key is within this bucket and a few other configs, everything structured in JSON format. AWS IAM then gives you the ability to add an OpenID Connect IDP through console or CLI, and that can be pointed to this public S3 URL that it just created, which hosts the JWK's endpoint. Why S3? It's simply because it gives you the public endpoint out of the box without having to run your own web server to host this JSON web key set. Customers usually have very strict restrictions, security restrictions around exposing public S3 endpoints within their AWS accounts. So that's the reason we have intentionally placed this S3 bucket in a Red Hat own account. Coming back, the OIDC provider created here can then be used as a principal in an AWS IAM role within its trust policy. That's how trust is established between AWS and the OIDC provider. If we were to see how it looks in the console, there is this option to add an OIDC provider. You choose OpenID Connect option and then provide the public JWK's endpoint. Audiences are nothing but client IDs that's given to clients or applications to use it or bring it along to identify themselves when they want to talk to the OIDC provider. So it's very similar to any kind of application registration with popular identity providers, for example, Azure AD, where you get a client ID, right? Here it's called audience. Uh, and this is how, so, sorry, this is how the OIDC provider configuration looks like for a ROSA cluster. So here you've got the provider details that points to the S3 bucket, and then you have the audience definition here. Once you have added a provider, they can straight off use that to assign roles, AWS IAM roles that honor that only that provider, right? So you can create web identity roles, based roles, right? Uh, in the trust, if you look at a role that gets created, this is one of the OpenShift ROSA operator roles that gets created. If you go to the trust relationship section, You can notice that the condition provided here that says not not only that that the requester, or rather the web identity, should be identified through this OIDC IDP, but also that it should very specifically originate from this namespace and this particular service account within that namespace, right? So pretty much restricted or confined to this subject. No one else will be allowed to assume this role. Now, how is all this information checked in a role assumption request, right? When you look at the core cluster operators, the deployment spec has got something called a projected service account token. It's kind of a volume projection, basically a Kubernetes construct that is periodically rotated by the cluster itself. In ROSA's case, every hour. If you look at the projected token, right, in the deployment spec, it's an OIDC JSON web token with details such as expiry and namespace, service account details, audience, uh, the OIDC issuer, who signed this token, etc. All this information is made available through specific configuration variables at the cluster level or through the projection itself. So any core operator that has this projected token in its spec, OpenShift identifies such tokens and periodically encrypts that projected token using uh, the private key that was initially created during the key pair creation process. This is how the token looks like when it's passed to the IAM by the operator code. So here, if you look closely, you can see, that the issuer details are specified, the expiry and the issued at time, the audience, uh, the service account, you know, the subject that goes that's defined within the role, right, in the trust relationship. So everything is the namespace and the service account details. Everything is mentioned here. Additionally, these core operator namespaces will also have a secret with two values. One is the role errand that this operator wants to assume, and the other is the path to the projected token within the pod. So this is what the projection attaches to the pod. So the path is also mentioned in the secret. And the AWS SDK client code that runs within these operators understands and looks for these two secret values. And whenever it needs to assume the AWS IAM role to access EC2 or any service that the operator is responsible for accessing, the SDK then invokes something called assume role with web identity API call. Uh, it calls to AWS IAM asking for the AWS role credentials in exchange of the OpenShift issued and signed OIDC token that it already has with it, right? And the IAM then validates the received token against the OIDC providers that it trusts. In the case of ROSA, this will be the provider that the installer added initially. Here, the signed token is validated against the OIDC public key details that is retrieved and cached by AWS IAM from S3. And once validation is complete and successful, uh, IAM then checks if the requested role has a trust relationship that allows the specific subject, that's a namespace plus service account, if it's assumed, if it is allowed to assume this role. If all is good, then temporary AWS credentials uh, are returned to the client, that is to the cluster operator port, which can then use that credentials to invoke AWS resource APIs that this assumed role has the privilege to access. This is how STS operators or STS operations happen for the core cluster operators of ROSA. In the case of third-party operators that need to use AWS roles, that's out of scope for this discussion, but the process of attaching a projected service account token and the signing of tokens is slightly different and is managed by the pod identity webhook uh, that watches out for specific annotations in the service account within that third-party operator namespace. The rest of the process about passing the token and web identity call to IAM for credentials are all the same. So that's it. Yeah, that's all about how STS works behind the scenes.